Good afternoon. My name is Paul Andersen, and I will be giving this webinar here at 3 o'clock Danish time. And it's about our software solution for structural health monitoring. We call it ARTeMIS-SHM. I'd like to give you a short introduction to the different parts of it and how it hopefully can help making it easier to make health monitoring. So let's see, I have a little outline here of what I'd like to go through. There is an introduction now for structural health monitoring and ARTeMIS-SHM. Then I'd like to demonstrate a little bit about it using a couple of case studies. And then after that, I will introduce some of the things that we have been doing in our new upcoming version of ARTeMIS. Especially this will be this new analysis history that we have implemented, where we are doing different types of SHM analysis. And then finally, I'll give some remarks. So we'll start out with some introduction, and you could start asking what is the purpose of doing vibration-based structural health monitoring. And it's actually, you would say, the monitoring of the dynamic behavior of the structure that we are looking at. We'd like to track if there are any changes over time of this behavior here. And if there is any kind of behavior, then give an alarm or alert to different recipients that would like to know this information here to be able to act. And you could say it all starts with a fundamental thing, because it starts with what we call modal parameters. We are trying to describe the dynamic behavior of the structure based on modal analysis. And the modal analysis is extracting modal parameters from the measurements that we can do. So you can say that these modal parameters, they in some way is a kind of a fingerprint of the structure. And as long as this fingerprint here is not changing over time, we are very happy, because that means that the dynamic behavior is not changing, and that ultimately also means that there are no damage or anything else occurring that is changing the structure here. So what we are doing in structural health monitoring is we are trying to look at the fingerprint, the modal parameters, and check if they are changing or not. Sometimes they are changing very slowly. If you have some deterioration that takes long time to act, like corrosion, for example, then you will have a very slow change of these modal parameters. You can also have something that enables a rapidly growing damage. That could be an earthquake. It could be flooding. Something else that happens here now that has a serious impact on the performance of the structure. So there are both things that has to be kept track of, both the slowly growing and the very rapidly growing changes that can cause damage. Just to give an example how a modal parameter is, what it is, we can try and look at this high-rise building here. A modal parameter is a mode shape. So this is one way that the structure can deform at a certain frequency, you would say. Normally it does it at, you would say, the natural frequency. This is the one that is also described here as a kind of one of the mode parameters. There is also the damping ratio. That is another one of the mode parameters. Mode shape, natural frequency, and damping ratio all describe one dynamic mode of the structure. And there is always a series of modes that are determined within the frequency range that we are measuring in. And it's then up to the, you would say, health monitoring system to keep track of all of these and check if they are changing or not. And you would say the more accurate we are able to determine this fingerprint here, the more or the sooner we can actually detect if there is a damage. And we have then also a better chance, if we can do it soon, to actually initiate some kind of repair to prevent loss of, you would say, lives and economy, and also other unnecessary costs. Besides that, you could say the accuracy of the fingerprint here, the modal parameters, is actually depending on the hardware that we're using, the sensors, the data acquisition system, and of course also the analysis software. And that's the part where we, you could say, add to this chain here. When it comes to the analysis requirements, you could say we have to be able to track potential changes, and to do that, we need to have a kind of a baseline set up first. So we need to measure for a while, and during this time, we have to assume that the structure is behaving in its normal, you could say, state, that there is no actually damage going on at this moment here, because we need a series of measurements that allows us to set up a baseline for this structural health monitoring. And that really doesn't matter what type of analysis we are doing inside the software we are using. They all need some kind of baseline, because we need something to compare against when we are doing, you could say, the health monitoring. The next thing we have to do after setting up a baseline is, of course, to start a measurement, and then doing, you could say, repeated measurement over and over, and extract, you could say, the information every time we have a new measurement and compare with the baseline. And of course, it would be very desirable if you can make the measurements continuously, because that will enable you actually to react if there are any sudden events, severe events like earthquakes happening to the structure. If you only are measuring it, let's say once per 2 years or something, and then compare with the baseline, then you cannot really act in between these periods if you don't have any measurements there. So it's a really good idea to have a continuous monitoring system installed on your structure. And of course, if there is some kind of change detected, we should be able actually also to submit some notifications immediately after, and that could be SMS or emails or other things, so that the proper recipients, they can actually take actions as soon as possible. In our case, they can log in, of course, to a web portal also, and then check out what has actually caused the notification. What type of analysis is it that is causing this? So this is the kind of requirements that at least we have for a health monitoring system, or the analysis part of it. What we have done is then we have tried to design ARTeMIS-SHM to be able to handle all of this. And it's all centered, you could say, around our software called ARTeMIS Modal. That is a Windows-based application that can run either as a graphical user interface, or it can run transparently as a service, a Windows service, so that you don't really have to have any user account open or anything in order to make it run. So you can imagine that you set up the analysis for a structure using the graphical user interface of ARTeMIS, and then once you have set it up and you have started the actual monitoring part of it, you close the GUI, and then you start the Windows service instead. And what this service is doing then is it's monitoring, you could say, a folder somewhere on your network. When new data is arriving for a structure from the data acquisition system on a structure, then this data is then loaded into ARTeMIS, it's being analyzed, and it's being saved. It is saved to a project file, but it's also saved to an SQL server database where the results are then lying and they're ready to be viewed by other tools. You can also have multiple structures, you could say, dumping data into different folders on your network, so that you can monitor several structures with the same license. The way it's done then by this service is that it's sequentially analyzing the different structures, taking the data from one folder, analyzing it, storing it, going to the next, grabbing the data, analyzing and storing it. So it's looping through all the structures that you have connected with this specific service here. And in this way, you can make, say, 100% use of ARTeMIS for multiple structures at the same time. All of this is, of course, configured by the graphical user interface, and it's saved down to an XML file that the service is then using to figure out what to do, which structures to analyze, and when to analyze them, and so on. As I said, results are stored to the SQL database here, and along with you could say mode parameters and damage indicators and so on, there is also alerts being stored if something has triggered an alert inside ARTeMIS Modal. And we have then a notification service that is scanning the database all the time, and the minute there is an alert somewhere, then it can then react, grab hold of the list of recipients that should have an SMS or an email, and send out this alert to them. They can then connect through our web interface, that is this web address here, ARTeMIS-SHM.com. They can connect to this one here, and then they can actually see what has caused this alert. This is, you could say, in essence, what ARTeMIS-SHM is doing. It is connecting all the bits and pieces so that you can come from your data that comes from the data acquisition system, and then get results presented on a web portal where multiple people can access the same or different data from a structure at the same time. There is a bunch of licenses that are required in order to make this run when it comes to ARTeMIS Modal. So you could say you have to have the ARTeMIS Modal Pro Enterprise version of the software running. This allows you then to do operational mode analysis. But besides that, you will need something that allows you to analyze multiple measurements in the same project. And to do that, there is something called Data Manager Base module here that configures ARTeMIS to be able to analyze continuously the same project over and over again with new data. There is also a Windows service that is required. This is the one that allows all this sequential analysis of different structures, and it also allows you not to having to run ARTeMIS all the time in a computer. There is another one. This is an automatic file upload feature. This module here allows ARTeMIS to scan the different folders and automatically load data when something is being saved by the data acquisition system. Then regarding the analysis, there is this continuous mode track, mode parameter history. This allows the software to actually track different modes over time, how they actually are changing, if they are changing, or how they are just looking. It's tracking the frequency, damping, and mode shapes, and so on. And then we have damage detection module also, with different types of damage detection algorithms implemented that also runs, you could say, continuously analyzing the different data as it comes into the project. We also have some other things like interstory drift analysis, another module that can be used if you want to study, you could say, continuously local problems. For example, columns. You want to study how much interstory drift the different columns they have while you're doing the analysis. This is good for, let's say, if you have some high-rise building and you have some columns that are quite important, then you can actually add this module as well. So this is the type of licenses that are required in order to run the ARTeMIS-SHM system. Let's just have a brief look at how we can configure, you could say, ARTeMIS Modal to set up a baseline, and then also try to compare over time and see how modes are changing and how damage detection is working also. I have this little case study here from an Italian bridge that was severely damaged back in 2003. and it was then later decided to demolish it. But before that, some Italian researchers, they were allowed to do some testing, introduce some progressive damage, and do ambient vibration test on this part here of the structure. So this side span here was then subjected to different things. And this is the data that I'm going to use here. It's a short or small set of data, but it illustrates very nicely how things should be set up. And you can see here how the different sensors, they have been located here across this section of the bridge here, and you can also see some of the damaging that these guys were doing to this structure here before it was demolished. So let's see, we can try to go now to ARTeMIS Modal. Let's see if I can find it here somewhere. I already have uploaded the files. We have 8 files that are in a, you could say, reference state. That means the recording was started before they started doing any kind of damaging on this structure here. And then while they were doing the damaging, they were then recording these files here, the rest of them. So there is some progressive damage going on at this part here. So just to save time, I already uploaded these files here, and I was just running operational mode analysis using our SSI tool. And this is what you can actually see now on the screen here in our analysis history here. This is the modal parameter history module that you can see. And what you see here is the natural frequencies from the first measurement here. This is the first mode of the first measurement I'm pointing at here, and this is the first mode of the last measurement that I'm pointing at here. So this is the natural frequencies that you can see how they appear here over time. And up here we then have the different frequencies that has been extracted. And the first thing we have to do is we have to assume, first of all, that we have some measurements that has been taken in a reference state, where we can assume that everything is good with the structure, no damage is introduced, whatever is going on there is natural behavior of measurements. The first 6 sessions, as we call it here, they will be considered as our, you could say, baseline, our reference part of this data here. So what I have to do is I have to then configure that this is my baseline, and I do that, and we call this, you say, estimate reference mode, this step here. Because what I like to do here is actually I like to find modes that looks the same across these, let's say, 6 sessions here. So these I'm pointing at here, they look to be the same. So the structure will try to identify if they are in fact looking the same. And if they are looking the same, it will then make an average of the frequency, the damping, and the mode shape of these 6 values, or 6 modes. And then you will give, it will then return what we call a reference mode. And that will be a kind of an average of what has been found here. We use that average mode as our baseline for this mode here. And then we will be tracking how things are then changing for that mode across the different measurements. But the first thing we have to do is we have to allow the software to identify these reference modes. And that's what we do up here in this first step here. So I will tell that I will let the software start looking from the first measurement and then to the 6th measurement here. And we can then tell a little bit about how many tolerances, or how much tolerance we will allow for the different things. We can say that we can allow up to 10% deviation of the different frequencies when you compare them across to one another. Here we have set that the damping, we can allow up to 1000% change, and that's because we really don't care right now about the damping. But if damping is a very important thing for you, then of course you have to reduce this tolerance to something much smaller. The next thing is the mode shape. Here again, we can say that, okay, when we compare the mode shapes of these different modes, they can calculate the MAC value between them, which the MAC is this correlation measure that looks at how much they look like each other, these vectors. So we set it to 0.8 which means that they should look quite a lot like each other. The next you can configure is then how many of the sessions here, of these 6 sessions here, how many of them should have, you would say, a value of the frequency damping and mode shape in it, in order for this to be, you could say, considered as a reference mode. If you set it to 80 here, that means 80% of the 6 here would be okay. I would like to say, okay, let's set it to 100. That means that all 6 sessions should actually have this particular mode found in it in order for us to, you could say, consider it as a reference mode. So once we have done this and we have selected the method that we have modes from, and this is done automatically, as you can see here, then we just hit the start button, and then things are grayed out a little bit here. You can now see 3 values here, or 3 sets of values. These are the reference modes, as you can see. So there is one found at 10 Hz, then one at 36. They are also shown here with stipple lines. So we have these 3 here. So these are the 3 places where we in all 6 sessions have been able to find something that looks the same. And now we have a starting point. This is our baseline that we have, that we can actually start to use for a mode tracking. And the actual tracking of modes over time is then performed in step 2 here, like this. And now we have, you would say, how it looks. If we were now, you could say, initializing that data could be uploaded automatically, this mode tracking would just continue over and over again automatically. It just has to be configured once, and then automatically it will be updated as new data is being imported and analyzed. So this is just an initial step that has to be done inside the graphical user interface of ARTeMIS. The values here, the track modes as we call it, they are also stored to the database, and in this way we can get it and we can show it on our web portal later on, and we can use it of course also for tracking if there are changes. But we can see here that around here that suddenly the frequencies, all 3 of them, in fact, they are changing. They are becoming smaller, which of course indicates that there are some kind of loss of stiffness here that is tracking, of course, in this case here. So around here we see that something is happening, but we cannot, you could say, be 100% sure because we have only used one technique here. We should try to use more techniques, and that's why we have other tools also that we can run in parallel that allows us to look at the data in another way. And we have the damage detection tools available also. We can try to select one of them. This is the classic one. What it does is it starts again estimating a baseline model from some reference measurements, and then it establishes actually a threshold, or actually 2 thresholds, based on the measurements that we have selected. And once that is done, then you can start a second step that is actually your damage detection, that again can then run automatically. So there are, in this case, actually 3 steps we have to go through. The first is we have to create this reference or baseline model. Then we have to do a little bit of validation to this. And once we are okay and we accept it, then we can start the damage detection. So the first thing we have to do is we have to create this reference here. And as you can see, we have something similar as we had before. We have to start selecting what sessions we would like to use to create this baseline model here. We start from the first measurement, and then we will select up to the number 6 measurement here. The rest of these I will not talk so much about today here, but this is settings for the damage detection. We'll just keep them at these values that has been set up automatically here, and then we will click the start button here. And then something is happening. We can probably see something down here going on. And you can now see this is the end of the first step that has been performed here. we created this reference state model, as we call it here in damage detection. This is our baseline. We then took each of the measurements and we tested, you could say, a state-based model that can be created from that measurement and tested it up against the baseline model. There is, you would say, we subtract these two from one another, and that gives us a value, a damage indicator that has a certain size. This is a so-called chi-square test we are doing. So what you see here is a chi-square value. So it's basically a distance measure. So we do that for all 6 of these measurements here. And once we have done that, the reference state where everything is okay, we can then use it to compute 2 thresholds. So we have to calculate, you could say, the mean value and the standard deviation, and then we multiply the standard deviation with some kind of significance level, and then we get a 95% threshold here, confidence level here, and a one for 99% over here. So we have these 2 here that are that serves as our thresholds. If we are below those, everything is good. We are still having data that are distributed like the one we had in the reference state. If we exceed some of these thresholds, then it's getting bad, because then suddenly we do not have the same kind of distribution anymore. We're not inside the distribution of our reference state, and that means that something has changed. The dynamics has changed of this structure here. And what is really good about this technique here is that when you have a slight change, it reacts really heavily. And that means that you can really see when damage starts to occur. So let's see here, the next step we have to do is we have to in some way reassure ourselves that this model we now have tested with data that has been used to set up the model, that model can actually also still perform good if we try to take some other data that is still considered to be in reference, but it is not data that has been used to construct the baseline model. We call this step validation. And what we do is we go to our second step here, and now we will say we will try to grab some data that we still believe is in an undamaged state, in a reference state, and then we will compute the same kind of damage indicators between the baseline model and now this new data here, and we should then still be below our thresholds. If we are not below the thresholds, it means that our baseline model is not good enough. It does not contain enough information to actually be able to also you could say accommodate for anything that is in these measurements here. So this is a crucial step, I would say, for the damage detection that we should do. And we have 2 more records here, 2 more measurements that we know are taken before the actual damaging was done, and we use those for the validation. And you can see that you still are in the green. That means you are below these thresholds here, and everything seems to perform very good with this baseline model here. Then we can start the damage detection. So now we can just enable it, and all measurements that has not been processed and all new measurements that are being uploaded later on, they will now be processed and compared against this baseline model. So we just start this part here, and you can see immediately when we start getting the new measurements in, we get a significant, you could say, reaction here from the damage indicator. This is a logarithmic axis. So there is a huge amount of difference between this point here and then the ones we have down here. So this is a really, really sensitive tool when it comes to damage. We can try to just overlay this so we can see the 2 things together. So here it's clear to say, as you see, that when we have indication of damage here, this is also when we have the change up here, as we can see, of our modes. The frequencies are dropping here, which was already at that time the indication that something was wrong here. So this is parallel tools We have many more we can add, of course, but this is just to illustrate how you can actually set up a baseline. You have to do that for all the different methods, and how you can then in parallel do this kind of analysis. And because you are using multiple tools, you can also in this way reduce the risk of getting false alarms that is caused by, you could say, computational things in the different analysis tools. Let's go back and see, we have, the presentation here. Because now we want to switch to another case study that's a little bit more advanced. This is this bridge here. Again, it was a bridge that was decided that it was no longer usable for some reason. And some researchers across Europe had this IRIS project where they then were allowed to introduce damage here and then do continuous measurements on it, the structure here, while they were introducing these damage. So we have a larger set of data available here that is really nice to work with also. You can actually see here how they have split the different damaging they did. Of course, they started out with I think they had 150 measurements in a reference state where they did not do anything. They was just starting the equipment and then measuring on the bridge as it was. But then they started doing all kind of things. So they actually cut through this column here a couple of times, and then they were lowering this column down. And then after a while, they were also lifting it up again and trying to replace or you would say repair it again by introducing some steel plates. And then they were also exposing some rebar cables and then cutting these in the girder itself. So there were different things happening to this bridge here. There is a nice report that I can recommend, I think, to if you want to read about this project here. But this is in essence what was going on with this structure here. So let's see. I think we have some modes here we can look at. This is the first 4 modes. So this is the mode shapes you can see here of this. You can see how the sensors, they were primarily located on one side of the structure here. And then they had a single, I think a triaxial located over here in this part here. So we have had to add some slate node equations, as we call it, in order to be able to actually compute the full mode shape movement on this side here. But anyway, this is some of the modes. This is analysis made by some of the reference measurements that we use for this. And then you can see here now, this is the results that we got from analyzing the 681 measurement files, or sessions as we call it. And you can actually see here how you get, this is the reference range here. Suddenly you get this jump here in the frequencies, as you can see here. And it matches very well with what you get from the different damage detection tools that we applied at the same time. This is how it's looking in ARTeMIS Modal. And what we can then do is, this is then stored to a database, and you can then access the results by going to a website, and I can try to see if I can access it here. I'll just start up a web browser here now. So we have a web browser here, and then I can say ARTeMIS-SHM like this. And then there is a demo account here. And then if I log in here, then I get this Google map here, where the different structures that we have on this account here is located. You can see the location, but you can also see the state of it. So it's red here. That means that we are in an unsafe state. This is the last measurement that was made on the bridge that you saw before. That one caused that you know, all the damage detection tools, or SSM tools, they reported back that there are so significant changes that overall you have an unsafe state. We can try click on this one here, then we can actually see the state reported here. We can also try to go here and check out the details. And then you get into this dashboard here where you can actually see, you can zoom in here and you can then see all the sensor positions here as we talked about before, where we only have this single triaxial sensor over here. Here you can then see, you could say, the overall or the status, you could say, of the latest measurement. So you can imagine if you have an ongoing monitoring of a structure, that will be your latest one from perhaps 1 hour ago or something. But here, of course, we stopped, so there's not anything new to report from today. You can actually see the list of all the measurement that has been processed. It's lying over here, and the last one that we are at here, the one we have selected, is the one we see the results from here. And here you can then see what has been applied and what is the result of it. There are 3 different damage detection tools running in parallel. These are then also added together into what we call a control chart. So because all of these are reporting that we are in an unsafe state, red signals, then of course the control chart will also report the same. Then at the same time we have some operational mode analysis going on. There are 4 modes that are being tracked. You could say reference mode was made in the beginning and then tracked over time. You can see that this one here, this is one at 4 Hertz. This one reports that you are outside the interval that we have calculated for being inside the, you could say, safe region. So you are actually now in an unsafe state of this one because it has changed so much that that it is outside, you could say, the 99% confidence interval for this mode here. The next one here is grayed out, and that's a little bit strange, but that means that it's no longer available. So it's actually a reference mode that was made up in the baseline, but it is no longer possible for us to track it because of the damage. The damage has caused so severe change of this bridge here that this mode here has completely disappeared and changed into something else. Then there is the third mode here. This one is green, and that means that this mode actually looks like in the baseline on the reference part. So it has actually undergone kind of a change because it actually started decaying and then it came up again as they were lifting up the girder or the pier again and inserting these steel plates here. So it's not all the modes, as you can see, that are reacting. Some are disappeared completely, but some are actually unchanged when you compare with the initial conditions. Down here we have some alert status coming out. These are the alerts that can be sent out with SMS and emails when something is happening. Let's see, you can then go and check out details. So if you go up here, you can click on this analysis here. And now you can actually go to and check out what you want to look at from this tree structure here. You have to select, let's say you want to have a geometry. You could also look at statistics from all the different things. There are possible things like all this stuff here. But let's for now look at the modes. So for the selected session down here, we can then try to see a table of all the modes. Then we can animate the mode shapes. We can also try to look at how the frequency is changing over time from the first to the last measurement we have available. And we can also look at the damage detection. Here we can try to just grab control chart. Whoops. And then once we have selected what we want to see, then we just click the update like this. And you can see here now, we get again the same geometry here. We can try to start some animation here. It looks a bit funny, but it's because we have a kind of a transversal mode here acting like this. We can also try to look at another one here. So here you can then see another one as a higher order bending mode of some sort. That is a torsional mode that is showing up here. So here you have all the different modes from this particular session here showing up. And then later down here, you can also go down and you can then see the history of all the frequencies that has been tracked. There are 4 in this case here. You can see how at this moment here, suddenly this mode here disappear. So there's just a straight line from here to here where this mode is absent. It's not available for tracking anymore. But then as they lift it up again, or they insert this metal plate, so suddenly you can actually see how you can start track this mode here again. And the same for the other ones. You can see how they drop in a period of time and then they come up again at this moment here. So this is the mode tracking that has been done for all these modes here. And down here you can then at the same time see the damage indication. This is the control chart, but you could also have all the others showing up if you want. So you can get a detailed view here of whatever session you want to look at, but you can also get, you could say, the overall view of what has happened since the beginning. So you have all the details that you require in order to make some assessment about if there's any change or not to this structure here. So this is our web portal in essence, that what we have here, and you can log in multiple users. So you can have hundreds of people looking at the same data, which is not really the case when you have ARTeMIS, because it's a single user license normally, and there you have to have it installed on one computer. But this web portal here allows you actually to be multiple people looking at the same data or looking at different data in your organization at the same time. Yes, let's see. I think it's time now to just jump a little bit, because there is something I'd like to show you from our latest development. I'd like to show you this. This is on another server. We have this running here. This is actually our latest version of the software. This is version 8 of ARTeMIS Modal that you are looking at here now. It's just a part of it, but what I'd like to show you is some new things we have done in the analysis history, because we realized that when you have a lot of data from a structure that is being monitored, and then you start setting up, you say, a reference state model, you can get some false alarms, and they seem to depend on how you actually are configuring this reference state model. So instead of having to reconfigure every time and rerun the classic analysis, for example, we allow that the user of the software can actually insert as many classic and as many robust and as many control charts as they like, and then configure these differently and look at how they perform at the same time. And this is actually what you see here. Just for fun, I have tried to analyze this data here from the S101 bridge with 3 different versions of classic. And this is not possible in our current version of the software, but this is something that we are now releasing here, that you can actually go to classic here, and then you can simply right click here, and then you can add a new classic damage detection, for example. And then what you have to do is then you have to use the 3 steps for each of them that you have inserted, and then you can then get, you could say, each of them configured based on their own settings. And you can see here how I have used 3 different sets of settings. The first one here, I used the first 100 sessions or measurements here to set up the baseline model. When I did that, then I got a false alarm at this point here. And then I was thinking, okay, then I have to try to see how can I prevent this from happening, because there is actually no alarm here. There should not be any, there's no damage occurring. So this is actually a false alarm, false positive alarm. So what I did was I tried to increase it, and then I used up to 140 out of the 150 measurements that I had in the reference state. And then you can see in this case here, it disappeared, this false alarm. That means that the reference state model here is really covering all the bits and pieces that you have in all these measurements here. There's still something going on here, but it's you could see it's popping up no matter how I configure. So there is something here that is outside, you could say, the normal behavior of the rest of the measurements. I think it might be that someone has parked some big lorries or something on this structure here when they were setting up something in the beginning. I'm not sure. I have to check this with the people that actually did it. But it's very consistent that all the methods, they are actually reporting this no matter how we set it up. So this is what you can get from using multiple, you could say, configurations. You don't have to redo everything every time and then wait for hours before it finishes so you can see the new result. Here you can actually have things added side by side in this way here, and then figuring out much better. You're much better equipped to figuring out how to set up your reference state model. And of course, you can see all the other things like we have here, our mode tracking is also possible to see in the same. So we don't have this drop-down list up here anymore. It's now a tree structure here where everything is located, and you can then select what you would like to see in this diagram here. So this is some of the new things that we have added here to the next version that is coming out here in probably a month or two from now. We are ready to release this version here. Okay, let's see. I will just go back to the presentation here again. Just to give a final remark that you have hopefully got an impression about what it is that we have been doing. We have added this additional layer on top of our ARTeMIS Modal software, so that we now have, you could say, we are covering other things. We can better cover that you have multiple structures that you would like to you could say analyze with the same license. We can do that now sequentially using this approach here. We can store things into a database, which allow a notification service to actually report to people when something is happening, giving them notifications. And we can also we have also added this web portal layer that allows you to access the results through a web browser, and you can be many people at the same time accessing the information of a structure. So this is the ARTeMIS-SHM that is covering all of this. We are still, of course, using our ARTeMIS Modal. This is our computational engine. So you can still, of course, just use ARTeMIS Modal and all the different SHM plugins we have, if you don't need all this additional layer with the presentation and all this that you have seen here. ARTeMIS Modal is the workhorse of all of this, and this is the one that is producing all the results that you see. What we do is we have always take pride in that we are an open platform. You can actually get data in from many different file sources or file formats, and also other ways. But that means that we support many different hardware suppliers that are supplying data acquisition systems and continuous monitoring systems in general. And we also have another thing that we always have been doing. That is that we are not trusting a single, say, analysis algorithm. We always want to have multiple algorithms running at the same time, because this reduces the risk of, you could say, getting computational results, not physical results. So you will always see that no matter what we do, we always have multiple methods that can provide the results from the data. And this is both in SHM, but it's also in modal analysis that this is the case. And then the last thing is that we have our new upcoming version here, and this is where we are trying to, in a more, you could say, effective way, trying to account for that all these different damage detection tools, they are relying on some statistical tests, and they will all in some way return false positive alarms once in a while. That's simply not possible not to do. But the good thing is that if you configure them differently, the reference state part of it, these false alarms, they tend to not appear at the same time. And that means that you can actually then account for them, because you can just you can prevent the software from alerting people if there is not a consistent, say, alarm across all the different methods. This is some of the things that we are focusing on in our upcoming release. So with that, I think I'd like to just thank you and then tell you that there are some more information available on our YouTube channel that you can find the address of here. You can just write @ARTeMIS Modal when you go to YouTube. We also have our website where we have information in terms of literature, but you can also download the software and test it out. We also have a special section for our ARTeMIS-SHM system here. And then I want to advertise that we have our next training course next month here in Denmark, in Aalborg, where we are. And you can see more about this in this part of our website. And then finally, we will go to the next IOMAC conference in Naples, in Italy, which will be held in May. And here we will have an exhibition booth, and I hope to see some of you there. And you can then see the new things we have in our latest release of ARTeMIS. Thank you very much.